Okay, morning, guys. I hope you had a nice weekend. I am going to start by going through the homework. Now, I had started this in class on Friday, um, so I'm just going to. Here we go. Sorry, this hasn't synced to my iPad for some reason. Just give me a sec. So I'm going to finish this. I had done the left-hand side, so class 1 of the stem and leaf. I just hadn't done class 2, so that's where I'm going to pick it up. Okay, so class 2, 34, 35, 36, 38. Okay, so all the 30s are done. I really hope it doesn't start going slow. Okay, I'll keep going anyway. So we have 40, 2 41s, 2 42s, and 2 43s. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, it's catching up there. I won't shut it down just yet. Okay, so maybe I will. Sorry. Okay, so I'm on to the mid to high 40s. So I have 45, 45, 1, 2, and then 46, 46, 47, 47, 48, 49. 50, 50, so 50, 50, 51, 50, oh no, 51, 56 then goes down to the next one, 57, 58, 58, and then 64. Okay, and then I thought I did this the other day, but you pick something, so I'll pick this one. So we have 5, line 6 is 56 sit-ups. Okay, so part B there you can just about see what was the minimum number of sit-ups by a student in a test. Okay, so the minimum number in class 1 was 32 and the minimum number in class 2 was 34. So the minimum number was 32 sit-ups. What was the maximum number of sit-ups? So it helps that these are in order. They're not always in order like this, but the maximum number of sit-ups from class 1 was 63 and the maximum number of sit-ups from class 2 was 64. Sorry. So 64 is the max. Complete the following table. Okay. So class 2, between 30 and 34, there were okay. So between 35 and 39 for class 1. So that's these guys here. So there's 2. Same thing for class 2 is 3. I'll do the percentages in a minute. Then here we have 3, and on this side apparently we have 7. 1, 2, 3, 4, 5, 6. Yep, we do 7. Okay, so now the next one, I'm here. 1, 2, 3, 4, 5, I have 6 there. And then on the other side, 1, 2, 3, 4, 5, 6, 7, 8 on that side. 50 to 54, so I'm back here. 1, 2, 3, 4, 5, that's 6. And then on the far side, That's 3. Yeah. Next we have 1, 2, 3, 4, 5. That's 6 again. And on the other side we have 3 again. And then we have 3 and 1. Okay. So percentage of class. So if I'm going to do percentage of class, I'm going to need to know how many people are in the class. Do they tell me that? If I go back up to this, no. Okay, I'll have to count them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And the same again. So I have 28 in class 1. Is this the same? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 by 2. So that's 26 in class 2. Okay, so 28 in class 1, 26 in class 2. So I'm just going to write that 28 and 26. Okay, so if I'm going to figure out the percentage of class 1, I'm going to do 2 over 28 and then multiply by 100, and this is going to be 3 over 28 and multiply by 100, and then 6 over 28 and multiply by 100, and so on all the way across. So 2 over 28 multiplied by 100. It doesn't say anything about decimal places, but seeing as the 2 that are done, these ones have 1 decimal place, I think I might go with 1 decimal place. Yeah? So I'm going to just rub this out because I've no room. And it's 7.1%. 3 over 28 multiplied by 100. Rub this out is 10.7%. 6 over 28 times 100 is 21.4. Same again, 21.4. Same again, 21.4. They're all 6s, so I don't need to do it. And then 3 I've done already is 10.7. Yeah? Okay. So the next one then, I'm on class 2, so I'm going to do 3 over 26 times 100. I'm going to do 7 over 26 times 100, and so on. So 3 over 26 multiplied by 100 is 11.5. So take that out. Put in 11.5%. 7 over 26 times 100 is 26.9%. 8 divided by 26 times 100 is 30.8. Now I'm rounding these to 1 decimal place, okay? So make sure you're rounding. Yeah. Okay, the next one is 3 divided by 26 multiplied by 100. So that is, oh, I did that already, 11.5. And then the next one is 11.5. And then 1 divided by 26 times 100 is 3.8. Okay, there you go. Using the results from the table above, describe how each class performed. So I suppose we look at the percentages. It doesn't really matter what you talk about here. You kind of need to just talk about a few different things. Hang on, I'll just zoom out a little bit so I can do a bit of writing. So I suppose we could talk about the fact that 10.7% of class 1 did 60 or more sit-ups, but only 3.8% of class 2 did 60 or more. Okay, that would be a comment. I think, let's see, 21.4 plus 21.4 plus 21.4 plus 10.7. So that's like 74.9%. 30.8 plus 11.5 plus 11.5 plus 3.8. Yeah, that's only 57. So I'm looking there at like this bit of the data. So something like 74.9% of class 1 did, I'll move this over now, did 45 or more sit-ups, whereas only 57.6% of class 2 did 45 or more sit-ups. Okay, so that's what I have there. So 79%, nearly 75% even, of class 1 did 45 or more sit-ups, whereas only 57.6% of class 2 did 45 or more sit-ups. And then you could look at it from the other end. I mean, literally this is an analysis of the data, so you just have to take a couple of points. So if I look at the far end of it, like you could obviously, as in you could write that point the other way. You know, you could say whatever it is, approximately 25% of class 1 did less than 45 sit-ups, whereas it's going to be what, 43% approximately of class 2 that could only do less than 45 sit-ups. Okay, so then I'd make some kind of a comment like overall class 1 did better in this fitness test. Something like that. I mean, you can see it anyway if you look at the stem and leaf. Like, look where the data is. So all the data is towards the high end of class 1, whereas most of the data, so most of the people in class 2 did, the number of sit-ups they did was in the 40s, whereas in class 1 it was in the 50s. Like, look at the amount. There's 12 students there in the 50s in class 1, but there's only 6 in class 2. Okay? Statistics is always interesting in that kind of way, because you always wonder if you took a couple of these students out of class 2 and put them in with class 1 and they were watching people beside them doing more sit-ups or doing sit-ups faster, would they have been capable of going faster? But they were just matching the rest of the class. Do you know what I mean? And then you've this student, so actually the highest amount of sit-ups came from class 2, but this student, the class 2 just weren't as consistent. Most of the students were down here in the 40s. Yeah? So that's an analysis. There's no right or, well, no, you can do a bad analysis, but that's the kind of thing you're looking for. So you're trying to get an overall picture based on the numbers of who, in this case it was a fitness test, so who did better, which class overall had the better fitness test. Yeah? Oh, sorry. Okay, and then this one. So the back-to-back stem and leaf plot below compares the amount of time and hours spent by a group of first years and a group of second years on social media websites. So presumably the first years are on the left and the second years are on the right. Okay. List 4 possible values for the digit x. Oh, I didn't even see x. Oh, there's x. Didn't even see that. Okay, so what could x be? Okay, so to be there, it has to be, x has to be a 0, a 1, a 2, or a 3. Okay, because these are in numerical order, it can't be any bigger than 3 because a 3 comes next. So whatever x is, it has to be either smaller than 3 or it has to be 3. So that's either going to be a 0, meaning the number is 10, or it's a 1, meaning the number is 11, or it's a 2, making 12, or it's another 3. List two possible values of the digit y. Okay, so that's at the end, and it can't, there's an 8 before it, so it can't be smaller than 8, so it's either an 8 or it's a 9 for y. Okay, if 4x plus 3y equals 32, find the value of x and the value of y. Okay, but I've got loads of values. Okay, so I'm just going to have to try a few and see what happens. So 4 times 0 plus 3 times 8 equals 32. That's 0, and 3 8s are 24 equals 32, so no. Okay, so what's that? That was 0 and 8. 0 and 9, 3 9s are 27, so that's not going to work. I can do it, but it won't work. Plus 3 times 9 equals 32. Gone. 27 equals 32. No, it doesn't. Okay, so try the 1. 4 times 1 plus 3 times 8 equals 32. So that's 4 plus 3 8 to 24 equals 32. So that's 28 equals 32. Nope. With the 9, what does the 9 give me? 27. 27 and 4. That's 31, is it? That's 4 plus 27 equals 32. No, 31, I was right. 31 equals 32. It does not. Okay, 4 times 2 plus 3 times 8 equals 32. That's 8, and 24 equals 32. That's right. Yay. So the value of x was 2 and the value of y was 8. Cool. Okay, if the total time spent by the first year group amounts to 200 hours, find the value of p. Okay, so I'm just going to do it here because I can see it. I have 12 and 23 and 24 and 29. 30 something plus 37 plus 41. Is that right? 1, 2, 3, 4, 5, 6. Yeah, okay. So 12 plus 23 plus 24 plus 29 plus 37 plus 41. That comes to 166. So 200 minus 166 is 34. So, excuse me, I knew it was going to be 30 something. So the P is the 4. I like that question. Right, so this is going to be Monday. I'm just going to move down here. The 15th of March. Okay, so we go back into the chapter. So that's your back-to-back stem and leaf done. Okay, so we're going to look now at measure of spread. So we're going to look at range. Okay, so if I just go back up here to the top, range is one of the ones. See it there? Oh, sorry, I'm on the wrong one here. So range is there. Okay, so what we have... Wow, this is really messy. But this is what we have. Must have done this with my second years. Why is it so messy? I feel the need to fix it. I'm going to have to fix it. Okay, so what you should have learned from the first chapter is two things. So the first thing you have to learn are measures of central tendency. Okay, and central tendency is just a fancy way of saying average. Okay, the word, when you do an average, you're kind of trying to work out that central value. You're trying to work out what answer is in the middle. Okay, so there's three measures of center. The first one is mean, and that's where we add up and divide by the number of numbers. The second one is median, and that's where you rank and take the middle number. And the third one then is mode, and that is the number that appears most frequently in the data. Okay, now you need to be able to calculate all of them. Mode isn't really, sorry, I wrote most. Mode isn't really calculated, you just kind of look at it, but you need to be able to figure out all of them. You also need to know the shortcomings. So why is the mean a good average sometimes, but it's not a good average other times? Why is the median a good average sometimes? Do you know what I mean? So you need to know them. And then what we're doing today is messy. Measures of spread. Okay, and the same as sorry, another word for this is variability. I'll try and explain it now in a minute. Variability. Okay, so there's the range, which we're going to do today, which is really easy. It's basically highest minus lowest. And there are two other measures of spread, but we don't do them till leave insert. So there's interquartile range, which used to be on the junior cert, but it was taken off with this new course. And then the other one has always been leave insert. It's called standard deviation. Okay, so we will get to a point where we have three measures of center and three measures of spread, but at the moment, or for your junior cert, you have three measures of center and one measure of spread. So these two calculations are, as a pair, really good for analysis, okay? Because let's say, right, let's just say we had two higher level classes so we do have two higher level classes in second year, right? So it's my class, and then we have Mr. Cummins' class. So let's say Mr. Harrington wants to see, I don't know, he wants to put a class in for a competition and he wants to pick the best class, okay? So he asks us for our average grades for the year. So both myself and Mr. Cummins have both given the same tests, and my results look like, so I have, let's pretend I only have like 4 students just for ease here. Actually, do they have data? It would make it so much easier. Okay, so I'm not even going to try because I'll end up getting it wrong. So let's say my students, I submit my data, right? And my students, so Miss Connolly's class, have an average grade of 62%. Okay? And then Mr. Cummins submits his grades, and his class have an average of 62%. Okay, so we've submitted this to Mr. Harrington, and Mr. Harrington, obviously the whole point of his exercise was to figure out which class is better, and then this is what we've submitted. So has he learned anything? No. As far as he's concerned, these classes are exactly the same. Now, if you include a measure of spread, so if he comes back to me and he says, Miss Connolly, will you give me your range, please? Right? And I tell him that my range is 84%. And then he goes to Mr. Cummins and asks for a range. And Mr. Cummins says that his range is 20%. Okay? What that means is that, yes, my class got an average of 62%, but there's a massive difference between my best student and my worst student in terms of their grades. Okay, so my best student might have gotten, 97, 98%. But what should I do? Sorry. So say my best student, the student who scored the highest, got 98%, which is amazing. That means the lowest grade in my class was 14%. Okay? Whereas, if we look at Mr. Cummins' class, maybe his best grade was only 75%, but his lowest grade was 55%. Okay, so can you see how including the range actually gives you a much better picture where sometimes the average can fail? So you can end up with two lots of data where the average are almost identical, which means you know nothing, but include a range in that, and then all of a sudden you start to learn. So what's happening in my class is that I have a couple of really good students, really, really good students, who are pulling my average up. Whereas Mr. Cummins actually has a class full of much more consistent students. So he doesn't have the 98, 99 percenters, but overall his class are much more consistent and he doesn't have people failing. Okay, obviously this is not based on real life data, but do you get the idea? Okay, that's where a range or a measure of spread is important, okay, because it gives you an insight into the data. All right, so here's a question, we'll do this. Natasha surveyed some of her friends to find out how many texts they each received in a week. Her results are summarised in a stem and leaf plot. There's your stem and leaf plot. How many friends did Natasha survey? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So just be careful that you're not counting the stem, just the leaf. So 1, 2, 3, 4, 5. Yeah. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Natasha surveyed 24 friends, I think. Yeah, 24. How many friends received 23 texts? So we have to look in the 20 stem, and there's 1, there's 2. So 2 of her friends received 23 texts. Now, what is the modal number of texts? So the modal number is the same as asking for the mode. Okay, so what was the most? Here it is, look, I can see it. Yeah, there's 4 of them. Now remember, you have to include the stem so that they're not 3s, they are 33s. Okay, so the modal number of texts is 33. Now, what is the median number of texts? Okay, so I just want to show you a little median calculation here. Okay, so you do half of n, okay, where n is the number of pieces of data. Okay, so in this case, what was there? 24. So we do half of 24, which is 12. Okay, and then we look up the 12th and the next number. So the 12th and the 13th number, and we average. Okay, so we'll come back to this. Okay, you can do, I'm going to show you the other way of doing the median. You can just do the median by crossing off numbers, but there is a method to do it, and sometimes it's nice to have that method. So there's a method for an even number, which is what we have here, and there's also a method for an odd number as well. Okay, so when it's even, so when you half the number of pieces of data if what you get is a natural number. Then you have to look up that number and the next number. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. 11. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. So that's the 12th and that's the 13th. So we're looking at number, what's that, 24 and 27, and we divide by 2. So 24 plus 27 divided by 2, and we get 25.5. Is the median number of texts. Okay, now let me show you. Some of you might have done it this way, which is completely fine, where you cross off the first number and the last number, the second and the second last, the third number and the third last number, the fourth number and the fourth last number, the fifth number and the fifth last number, sixth number, sixth last, seventh, seventh last, eighth, eighth last, 9, ninth last, 10, 10th last, what am I on? Blue. 11 and 11th last. So it leaves 2 numbers. So when you have an even number of data points, it'll always leave you with 2. So you have to take those 2 numbers, and remember it's not 4 and 7. You have to include the stem, so it's 24 and 27, which is exactly what I did down here. 24 and 27 and divide them by 2. Okay, so the median number of texts is 25.5. What is the total number of texts received by Natasha's friends? Oh God. Okay, so I'm just going to show these into my calculator. It's 8 plus 9 plus 12 plus 16 plus 17 plus 18 plus 18 plus 20 plus 20 plus 23 plus 23 plus 24 plus 27 plus 32 plus 33, 33, 33, 33 plus 37 plus 38 plus 38 plus 41 plus 44 plus 46. Okay, so I'm getting 643 texts. Okay, be so careful about typing those in. Hopefully I didn't make any mistakes there. If I was in an exam, I'd be checking that again. Okay. Okay, so then what's the mean? So the mean is where we add up all the texts, which we just did, and we divide by the number of data points there. What was there, 24? So 643 divided by 24. I'm getting 26.7916, so 26.8 texts is the average, apparently. And then what is the range of the data? So to do the range, you do the highest minus the lowest. So the highest number of texts received by any of Natasha's friends was 46. The lowest was 8, so we just subtract them. Oh, 46 minus 8. 38 is the range. Okay, so that's a little recap on mean, mode, and median, and then a bit of work then on range, which is quite straightforward. Okay, so for homework, I kind of like this one. I think we might do the example, just do it blind, please. Don't go into your books because you're just wasting your time then. So do it as a piece of homework. It's a nice question. So yeah, they ask you to draw the stem and leaf, which I think is nice, and it's also a back-to-back stem and leaf. So you'll have to make that out. So draw the back-to-back. Find the range for each test. So for test 1 and test 2, find the median, find the mean. Compare the scores. Remember, the whole point of a back-to-back stem and leaf is to compare. So compare the scores. So that's similar to what we did with the fitness tests. And Hugh says that every student in the class must have done better on the second test than on the first. And is Hugh correct? So a little bit of analysis there. Yeah? Okay, so that's your homework for Wednesday. Thanks, guys.